Fifth unit is going to deal with applications of optical network. So what are the methods to implement optical network in a real time? These things will be covered in unit 5. Okay. So this is your syllabus. So principle of a SONET and WDM are a kind of multiplexing technique, and following things or other applications or other methodologies available to couple the fiber signal, optical signal over fiber over a long distance. Okay. So today we are going to focus on principle of SONET. So do you have any guess on SONET? What for it is used? DCN ல படிச்சிருக்கீங்க SONET. Synchronous optical network. Very good. Sivaprakash, your answer is right. வேற என்ன வேற என்ன தெரியும் synchronous optical network பத்தி? What is SGH? You are right. Synchronous in the sense what? Yes. Okay. Let me show you an example. What is this? Janani. What is happening over here? Janani are from the figure what you can understand. Okay, Pavitra.
Yes, ma'am.
Yeah, from this figure what you can understand.
ஜட பின்னிட்டு இருக்காங்க மேம்.
ஓகே. வை அது வந்து ஃப்ரீ ஹேராவே விட்டுருக்கலாம்ல. அது எதுக்கு ஒரு ஆர்கனைஸ்டா ஒரு ஃபேஷனேட்டடா பண்றாங்க?
பார்க்க நல்லா இருக்கும்.
ஓகே.
தெரியல மேம் ஏன்.
Right. So since it is not oriented properly, we are doing something systematically in order to orient it properly. Okay. Systematically ஒரு set of protocol follow பண்றதுனால you can organize your hair in a proper manner. Okay. இந்த ஆர்கனைசேஷன் நடக்கும் போது ஒழுங்கா பிளாட் பண்ணலனா லுக் வந்து ஒழுங்கா இருக்காது. இட் will not be right. அது எதுக்கு பண்ணோம் அப்படின்ற அர்த்தமே இல்லாம இருக்கும். சரி, இத பாருங்க அடுத்தது. they are different, right? இங்க பாத்தீங்கன்னா பேக் சைடுல பண்ணிருக்காங்க, இங்க என்ன சைடுல பண்ணிருக்காங்க. So however, is it okay? Can you go in this manner to the school? So standard, with respect to the standard, you cannot go to the school in this manner or in this plot. So if you want to go to the school, there is a set of protocol that is to be followed, and this is the fashion you should go to the school by having a proper plot. Though there are many methods of organizing the things, you have to organize yourself in a particular manner if you want to address something, right? So this is an example in which, though there are many plotting methods or organizing methods of your hair, you are supposed to organize your hair in a proper default manner if you want to go to school, right? You have to plot it in a three bisected manner, and you have to wear a ribbon over it, and the ribbon should be properly tied. Okay, you all remember this. So this is an example of multiplexing. Sometimes the things will not be organized. In order to organize multiple different things into a single stream, you need to make it organized, or you have to multiplex. You have to multiplex many into one. Okay. So multiplexing is many branches into one branch is called multiplexing, and demultiplexing is unplotting it. So in worldwide, in America, they will be plotting like this. In Japan, they'll be plotting like this, or in Asian countries, they'll be plotting like this. Okay. However, if it is going to be Indian school, this is the standard, isn't it? Similarly, following to the standard, see here, SONET and WDM are the universal standard to multiplex multiple branches into one branch. Okay. Through fiber optic cable, I'm going to couple multiple user information into one fiber. I repeat once again, through fiber optic cable, I'll be multiplexing multiple user data into one branch. For that, I need to follow a set of protocol worldwide. That should be same all over the world. Okay, in America also it should be standard. In Japan also it should be standard. Also in Asian countries, the multiplexing method should be standard. Okay, so SONET and WDM are the standard multiplexing techniques over which multiple data can be concised into one single branch and can be transmitted over single fiber. So SONET, synchronous optical network or synchronous digital hierarchy are the methods available to multiplex multiple data into one branch. Not only that, wavelength division multiplexing. Wavelength division multiplexing is also another method to combine multiple data into one stream. Okay, this belongs to first generation optical network and WDM belongs to second generation optical network. Let's see it. Okay, see here, the first generation optical network has FDDI, fiber distributed data interface, and synchronous optical network. The first method, FDDI, is an outdated method which is going to guarantee lesser data rate. So we have eradicated that, and currently we are using SONET, synchronous optical network. And in other parts of the world, in America it is called as synchronous optical network, and whereas in other parts of the world it is called as synchronous digital hierarchy. However, the protocol remains the same. It is going to multiplex many optical signal into one fiber, okay, such that it is organized properly, so that many users are transmitting over single fiber without any interference. And coming to the second generation is going to support still higher data rate, and the technique is wavelength division multiplexing and wavelength routing networking. And optical networking component is also integrated with this. So these three topics are there in your syllabus. Okay, the topics that were highlighted in green color are in your syllabus. First generation வந்து ஒன்னு பார்க்கிறோம், second generation வந்து ரெண்டு method பார்க்கிறோம். Okay, and this is an example for multiplexing, how multiplexing is happening. You have multiple data. In order to organize it in a synchronous manner, you need mux and demux at transmitter side and receiver side respectively, okay, with a proper clock. If the clock is proper, synchronization will be happening. If the synchronization is better, multiplexing and demultiplexing will happen in an proper manner. Okay, so multiple user data are transmitted over single fiber. This is a fiber connection, and this is your synchronous optical networking backbone. Okay, so let's see what is SONET here. So can you someone say as per our discussion so far, what is SONET? What are the major application of SONET? I'm seeing the chat window. I need the answer. What is SONET? Leave that synchronous optical network. I need what for we are using going for SONET. What is the main reason for going to SONET? Switching within feasible connection. Okay. So in through switching, what you are going to organize? What you are going to do? You're going to couple multiple data into one single stream without any interference or without any confusion. That is called multiplexing. So the main aim of SONET is to offer multiplexing in a standard worldwide manner. உலகத்துல இருக்கிற எல்லா ஆப்டிக்கல் கனெக்ஷனும் SONET மூலமா தான் மல்டிப்ளெக்ஸ் பண்றாங்க. Please understand that. Whatever may be the continent, all the continents are adhering to one particular standard called SONET standard, which is used for multiplexing. TCP OSI model Mary, இதுவும் ஒரு standard model. Okay. இதை தவிர வேற எதுவும் நீங்க யூஸ் பண்ணீங்கன்னா it will not be accepted. This is the standard agreed one. So let's see what is SONET and SDI. This is an introduction slide. So synchronous optical network, which is SONET, is a TDMA based optical network standard in North America, and in the rest of the world it is also called as synchronous digital hierarchy. So what it is going to provide is, it is going to provide physical layer standard for multiplexing. Physical layer in the sense, it is a first layer in your any model. Above that, you'll be having data link layer, network layer, and till application layer, you have 7 layers in OSI and 5 layers in TCP, right? Similarly, in SONET also, this is a standard, and obviously it will be having layering approach, right? Only if there is a layering approach, you'll have an organized flow of data. So in that manner, physical layer standard is defined using SONET. And what else it is going to provide is, it is also going to provide backward compatibility for ATM based, that is asynchronous time division multiplexing, and IP based transmission, the synchronous transfer protocol, this one. This is primarily used in internet. Also, this is a standard one which is used till now, internet protocol. It has IP version 4 and IP version 6 now. Even that can be compatible using SONET. Even the old technique and the advanced technique are being compatible using SONET. And it is going to provide a delay of only within 125 microsecond it can transmit data, and based on the version, whether it is OC1, optical connector 1, or optical connector N. If N is going to increase, data rate is going to increase. So N is nothing but your multiplexing rate. Whether I'm going to multiplex 25 branches or 125 branches or 1000 branches. If 1000 branches are being multiplexed, it is OC 1000. Okay. If 1000 branches are multiplexed over a single fiber, what does it mean? It is going to have higher data rate. Okay. Such kind of fiber width or fiber standard can be implemented there. Okay. And it is going to provide linear multiplexing and demultiplexing using an add drop multiplexer unit. So in SONET, you have a special device called add drop multiplexer that is going to simultaneously multiplex and demultiplex multiple user data, right? So one thing you have to remember is SONET is going to provide a physical layer standard for multiplexing user data, right? So what is the main principle of SONET? SONET standard enables interconnection of fiber optic transmission equipments. Equipments in the sense it can be ATM or IP or a LAN based connection or laptop, any kind of optical devices to be connected through the fiber can be done using SONET device. Okay. So interconnection of fiber optic transmission equipments from various vendors. The vendor can be Samsung, Apple, or any other Cisco. Any other networking vendors can be uh, accommodated over SONET devices. Okay, from various vendors through multiple owner truck networking. Okay, the basic transmission bit rate of SONET is 51.84 megabits per second. This is a basic standard. In previous days, it was supported only 51 Mbps. But nowadays, due to advanced techniques, SONET is going to support in terms of gigahertz. See here, in terms of megahertz, it is represented. If you convert it to gigahertz, it is 2.4 gigahertz. Current transmission and multiplexing standard for high speed signal. So SONET is also a current standard for high speed and multiplexing standard. So where it is called, as I already mentioned, SONET is a standard for North America, and it is also the same protocol is called as so-called as SDH in other rest of the world. Coming to SONET, you'll be having, this is your multiplexer unit. Okay, many to one, many devices are many different vendor devices are connected through SONET device, and SONET is going to multiplex many vendor information into one stream. So over 50 kilometers, obviously optical signal will fade away. That we have seen yesterday. Okay. So you need a regenerator that is going to boost the signal amplitude such that it is going still 50 kilometers further. And then you have a add drop multiplexer. This add drop multiplexer can allow multiple signal to enter, or it can allow multiple signal to leave the unit. Okay. At simultaneous manner, it can also allow signal to enter as well as it can allow to leave multiple signal. So it is called add drop. You can add multiple signal and you can extract multiple signal out. So this add drop unit, after that you have again a regenerator, and then at the receiver side you have a demultiplexer that is going to convert single signal into multiple Venda signals, okay, in a synchronous manner. So in this section, line, path are defined. What a section is? The units that are present between transmitter side and the regenerator is called section. Okay. And between add drop multiplexer and between the transmitter unit, it is called line. And the units that are going to be included between transmitter and receiver are called path. Okay. So I repeat, the section is a representation that is going to include your transmitter unit and the immediate net section called regenerator, and line is going to be spanning between transmitter side and your add drop multiplexer. And if you're going to indicate the units that are being included between transmitter and receiver, it is called as optical path. Okay. So entire path is going to be your optical path. And the same diagram is represented here. See here. Why have we represented the same diagram here? Here is the layering approach is implemented over here. So with respect to the figure at the bottom, block diagram of the SONET, the layering approach is also indicated over here. As you all know, there are three categories: path, line, and section. Between transmitter and receiver, the data will be handled through path, and between between transmitter and the add drop multiplexer, it will be called as line. All the data will be processed over line. And if it is going to be between transmitter side and the regenerator, it is going to be section. And as you all know, the entire network is going to be your optical network, and hence it is photonic layer. So physical layer is otherwise called as photonic layer in SONET. Okay, in SONET, this physical layer is called photonic layer. Okay, so this is the path through which optical signal is going to propagate. At transmitter side, this will pass through path, line, section, and photonic layer. And over a regenerator, it is going to have photonic and section layer alone. And at the regenerator, sorry, it is at add drop multiplexer, it is going to pass through 3 layers, and obviously at the receiver side it is going to have 4 layers. So this is the layering model of SONET with respect to the diagram which is shown below. Okay. Now coming to your frame structure. So at the section layer, till here the bits zeros and ones will be converted into what? Pulses, light pulses, right? That we have seen already. How the signal, the light signal is transmitted means the zeros and ones, whenever there is one, a blink will be there, and whenever zero is there, there will be no blink. Accordingly, at the receiver side, when the photo detector is going to detect a blink, it will be termed as 1. And if the photo detector over at the physical layer is going to find the absence of blink, it is considered as 1. So this zeros and ones will be moved to section layer. Okay, the 0 and 1 which is being detected over here will be moved to section layer, and this section from over here, from the section layer, frames will be formed. Okay, here the frames will be broken into zeros and ones and will be sent into light signal. Again, this light signal which is received at the receiver side will be termed into zeros and ones and will be framed into frames. So this is how at the data link layer, that is at the section layer, frames looks like. Okay. In OSI model, it is called data link layer, whereas in SONET, it is called section layer. Okay. So this is the frame structure. See, the length of one packet or one frame is going to be 90 bytes, out of which your payload length will be, leave this header 3 bytes. These 3 bytes can be ignored, and rest of the bytes will be 87 bytes. So 87 into 9 rows. See, only one row is indicated here. Multiples of 9 rows will be placed here. So 9 into 97 bytes will be your payload length. Okay, from the frame structure, you can understand that you can keep zeros and ones of 97 bytes, which is going to span over 9 rows. So this entire frame can be transmitted over 125 microseconds. Okay. Within 125 microsecond, it will be transmitted from transmitter to receiver whenever this frame structure is followed. Okay. So this is a standard for fabricating a frame. Okay. இது மாதிரி ஒரு defined length and width இருந்தாதான் particular time delay ல it can reach the receiver. That is within 125 nanoseconds it can reach the receiver. Yeah, next is your multiplexer that is used in a real-time scenario. So imagine this is your optical cable. Over the optical cable length, you will be having a SONET that is going to multiplex multiple user data and will be transmitted over a single fiber. So what are the multiple vendors that are available as? See, you have a LAN computers, phones, customer provinces like bank or MNC companies. All those traffics, data traffics can be forwarded through your SONET or an optical fiber cable. Okay. So coming to advantages, why we should use SONET? Without that, what is going to happen? So without that, multiplexing will not happen, management will not happen. Okay. You need SONET to interoperate multiplexing, management, networking, and to interface multiple user data. So how multiplexing is attained through SONET is, it is going to have a master clock that is going to synchronize transmitter and receiver at either sides. Next is management. It is not only going to multiplex. SONET is going to help you to manage multiple user data and can confine multiple traffic at a given time. Okay. So it is going to maintain operation, administration and management control. OAM சொல்லுவாங்க. OSI மாடலும் படிச்சிருக்கீங்க. OAM, operation, administration and management can be done using this advantage. Okay. Next is interoperability. As you all know, it is going to accommodate the oldest technique called ATM, and as well as IP based IP version 4 and 6 can also be integrated. So it is going to join hand with the oldest technique and the future technique as well. Hence, SONET is going to have a interoperability feature. Next is networking. Networking in the sense, if the network fails, how fast it is going to recover, how reliable it is. So comparatively, SONET is going to attain better reliability since it is going to have a lesser restoring time. Out of failure, it will restore immediately from the failure. Okay. So coming to networking also, it is going to attain a greater kind of achievements. So these are the advantages of SONET. Multiplexing, management, interoperability with the oldest technique as well as the future technique, and it is going to have a robust kind of networking. That is, it can recover from the failure at a short time. Coming to applications. So as you all know, SONET is a standard for universal connectivity. It is going to be a simple one that is going to connect many fiber optic cable in a single unit, and it can also carry ISDN data and broadband ISDN data. That is, your broadband ISDN data is the best example for BSNL. What you are using or enjoying now is your BSNL connection, right? Even at our college, we are using BSNL connection. So broadband ISDN, in the sense, it is going to support BSNL connection, as well as those huge data can be coupled through fiber optic cable. And it is also a better carrier for ATM cells, can support bandwidth on demand, can be used for backbone or totally replace other networking protocols such as SMDS and FDI. That is, these are the oldest technique. We have seen already in first generation, FDI and SMDI can be replaced with SONET. Okay. So there are some other disadvantages that are to be addressed in SONET. That is, it is having a huge overhead bed that can be reduced, and low bandwidth utilization ratio. So also efficiency and reliability cannot be attained at the same time. If I'm going to attain efficiency, I have to compromise in reliability. Or if I'm going to focus on reliability, there will be reduction in efficiency. Okay. So these two things are your optimization things to be attained. And since it is going to support multiple vendor applications, there is a risk of vulnerability. Okay. So in this class, we have seen the basic architecture of SONET, the basic principle of SONET, as well as layering approach of SONET and frame structure. And we have seen some of the advantages and disadvantages of SONET.